Hello, everybody. This is Mr. Storm, and this week we're going to learn about conditionals. This is probably, after variables, this is the next most important thing to understand with programming. So this video may be a bit longer than the others, just because I want to really make sure you understand what we're doing here. Because this is something you're going to use in every application from now on for the rest of the year. You will always use these concepts every time you sit down to write an application. Let's go ahead and get started. I'm going to make sure it's a console application first. I want it to be called Conditionals, and I will say this is the teacher edition. I'm going to make sure it's in my computer programming folder, which it is. I'm going to click OK. All right, now with conditionals, what we want to do is we want to find out how we can give our user more control over the application, right? So far, if you really think about it, what we've given them the ability to do is we've given them the ability to read what's on the screen and give us some information. We can store that information and then return that information at a different time and in a different context, which is great. It's, we've used it to create our Mad Libs program earlier in the year, so on and so forth. Variables really allowed us to give our user a bunch of control over the program. But what happens if we want to give our user the control over the or control as in branching opportunities within the program? For example, let's say we want to build a program that's going to ask our user their age, and depending on their age, we tell them whether or not they're old enough to vote, right? So in the United States, the voting age is 18. So let's say I'm going to create a new integer variable called age. And I'm not going to give it any value yet because, again, we don't know if our user is old enough. So let's say int age, and let's say console dot write and how old are you, right? And we're going to int dot try parse because we need to turn this number into a variable, right? We turn the string into a number, and it's going to be string, let's say new age, and we're going to give it, or no, string age, no, oh, console dot read line, and it's out to age. That's what it is. I forgot how to do a parse statement for a minute. It's been a long day. All right, console.readline out and age. So it's going to give us the age, right? How old are you? It's going to tell us how old they are. And then what we're going to do is we're going to take that age and we're going to say if age is greater than 18, then console.writeLine, you are old enough to vote. Okay. Now, so what we're doing here is I wrote this if keyword, right? And in the parentheses, I put the comparison or the conditional that I want to base this statement on. So if age is greater than 18, then what's inside these brackets underneath the if statement will actually run. And this can be as many lines of code as I want. I can have it do all kinds of stuff, right? I can have an entire application inside this if statement. And it will only run this code if this conditional returns as true. Now, in programming, true and false are what's called Boolean values. Boolean values. So we can create a Boolean value, and a Boolean value is just like an integer or a string or whatever. It's a data type, and Booleans will only store either true or false, right? So we can create a Boolean, let's say, we can even do it, expand this out a little bit. Let's say bool, because it's a Boolean, eligible, and we'll say equal to, or let's say, yeah, if age is greater than 18, then we'll say, oh, we want to create our Boolean up here first. That's one thing with variables. You want to create variables up at the top of the screen as much as you possibly can. So I'm going to create bool, because we want, if we create a Boolean inside of our if statement, then only that if statement will be able to use that Boolean, and we don't want that. So I'm going to create a Boolean called eligible. I'm going to say if age is greater than 18, then we'll set eligible to equal true. All right. So now we know what happens if our oh yeah, we've assigned it, but we haven't used it. We will use it though. So eligible is equal to true. Now, this is what happens if you're older than 18. If you're not, though, we need to figure out how to account for that, because what's going to happen is you're going to put in your age. It's going to check to see if you're old enough or if you're over the age of 18. If you're not, then it's going to skip all this. It's going to skip these lines here, and it's going to go to the next statement, which there is none. So what we want to do is we want to say else. Basically, if you're anything other than over the age of 18, then we set eligible to equal false, and console.writeLine, you are too young to vote. Okay, now there's some issues with our program. First of all, let's take a look at this Boolean statement again. It's going to return true if the person is 19, 20, 21, so on and so forth, up to 106, or however old people can be, right? But if you're 18, you're eligible to vote, right? So, but this doesn't account for 18, because this is just if you're bigger than 18. If the number here is bigger than 18, then it'll run this code. If I put in 18, 18 is not bigger than 18, so it's not going to run this code. It'll skip that and tell me I'm too young to vote, which we don't want that. So we're going to say if age is equal to or greater than. So equal to or greater than. So that's the way you do it. You put your greater than symbol and then an equal sign right after. And that will include 18, right? Perfect. We also need console.readLine so we can wait when our program's done. So let's go ahead and run this. We still haven't done anything with our eligible Boolean, but that's okay. We'll do something with it in a minute. And it's taken a minute to run. Build, finish. Okay, perfect. So it says, how old are you? I'm going to say I am exactly 18 years old. Now we just fixed our program, so it should actually determine that 18 is old enough to vote. So let's find out what happens when I hit enter. Hey, I'm old enough to vote. Perfect. Let's run it again and let's test it for a lower number. So how old are you? I am 2 years old. I'm too young to vote. So you can see just that one statement that we wrote, just this really quick if statement. If you're old enough, then you're old enough. Else, meaning anything other than that, you're too young, right? Just with that, we can create branches in our program that allow our user to go down those different branches and discover new parts of the application. Now our applications no longer have to be simply linear. We can create cool branches for them to travel down. All right, let's do something with this Boolean real quick. So we set eligible to be true or false based on this here. Now, what we could do is we could use that later to open up a new area of the program or whatever, but we could also use this if eligible. And because it's a Boolean, we don't actually have to compare it with anything because it knows that eligible, if we're saying if eligible, that's meaning if eligible equals true, right? So if eligible, then we can say console.writeLine right line. Good job on living long enough, right? So it's just a little extra statement that we can give to our users if eligible equals true. Now, here's the thing. We also could have just put it right here inside this if statement, but I'm trying to show you how Booleans work with conditionals. So let's go ahead and run that real quick and see what happens. So how old are you? I am 578 years old. You're old enough to vote. Good job on living long enough. Great. Let's try to do that with a lower number just to see. How old are you? I'm negative 90. You're too young to vote. And notice we didn't get the extra statement, but the program continued to run. It just said, oh, eligible's not true. So it just ignored that statement and moved on to the console read line. That's how if-else statements work. Perfect. All right, let's tag this section here. Perfect. All right. Now, moving on. So that's an if-else statement. Now we can use if-else statements for basically all of the conditionals that we want to check. Let's try to do an else if else if. Yeah, anyway, it's complicated to say it out loud, but you'll see what I mean in a second. Let's say I have a number or a piece of data that not only has two conditions, it could either be true or false, but I want it to have 3 or 4 or 7 or 19, right? What I can do is I can create a new statement called an if-else if. So the way this works is let's say we're building a, I don't know, like a number guessing game, right? So I will say int secret number. And let's say that secret number is 54, right? And I want to have my user guess a different number. So I'm going to say int user guess. And I'm not going to tell it what the user guess is because I don't know what the user guess is. The user hasn't entered it yet. I'm going to say console.read, or no, write line. And I'm going to say, oh, what happened there? I pushed the wrong key. Write line. And I want to say, enter your guess. I'm going to actually make this a write instead of a write line. And I'm going to do the to parse. I'm going to try to parse that. Copy. And instead of going out to age, it's going to go to user guess. Okay, so now we have a secret number, which is 54, and we have our user who's going to guess a new number. And if it matches 54, we want them to say you won. If it's too low, we want to say your number's too low. If it's too high, we want to say your number's too high, right? Very simple game, right? Okay, cool. So let's start structuring our if-else statement. So if secret number equals user guess. Now, that's a weird thing that I just did there, right? I did the two equal signs. Well, the reason for that is because if I write just one equal sign, then what it's going to do is it's going to try to make secret number be whatever user guess is. It's going to change what's inside of the secret number variable to be what's inside user guess. Instead of just comparing the two, it's going to actually change the value, which is not what we want. We want to just compare the two. So if those match, then we'll say console.writeLine you win. Okay. Now, let's say the number's too low. So else. Now, instead of doing an else and then just moving on, I can say else if, and then put another conditional in here. Secret, no. User guess is greater than secret number, then console.writeLine, your guess is too high. Okay, perfect. And then down here we can have as many else ifs as we want. We could just chain a bunch of else ifs together, but we only have one more condition, and so we will just do an else. Now, why do I not need to specify user guess less than secret number? Well, the reason is because we've already checked to see if it is exactly the same as user guess or as secret number, right? We check to see if these two numbers are exactly the same. If they're not, then we'll go to the else if, which is going to check to see if it's bigger, right? If it's not, then we really only have one possibility left. It has to be lower than what we've already guessed. It has to be, right? And so we don't need to do an extra statement checking to see if it's lower. We already know it has to be. It couldn't be anything else. It has to either be lower than, so two numbers, when you compare them, they either have to be equal, one's got to be higher than the other, one's got to be lower than the other. Those are the only three conditions. Okay, so let's see, else, and I'm going to say console.writeLine, your guess is too low. I'll put a period here too, just for sanity's sake. All right, so now at this point, our game should work. Let's put a read line here so that our game pauses when we want to play. Alrighty, so we still have our voting machine set up. Okay, so enter your guess for a number. I'm going to say, let's try to actually win the game this time. I'm going to say 54. Hey, I win. I got the number exactly on the secret number. Let's try higher. So enter my guess. Let's say 76. Your guess is too high. So that condition statement works properly. Oh, not that. Now let's try lower. Let's see, 12. Your 12 guess is too low. Okay, so now our number guessing game works. But that's a very simple thing. What if we wanted to do something a little bit more complicated, like checking multiple Boolean conditions in the same if statement to determine whether or not somebody won? Let's say hint, hint, wink, wink, nudge, nudge. You wanted to figure out how to compare multiple statements to figure out who won a game of rock, paper, scissors, which is something you may need to know how to do in a little bit because that's going to be your assignment this week. So let's look at multiple statements. All right. So in here, we want to do and statements, or not statements, and or not. Now, the cool thing about and, or, and not is basically this. So with an and statement, return true, and statements return true if all statements are true. So basically, if I have something that says 1 equals 1 and 2 equals 2, that's going to return true. Because, 1 equals 1 and 2 equals 2, that will be true. Because both statements are true. 1 does equal 1 and 2 does equal 2. But let's say if we have a statement that says 1 equals 2 and 2 equals 2, what do you think this is going to be? Well, this will be false. Because 2 does equal 2. That side of the statement is true. But over here, 1 equals 2, that's not true, right? 1 does not equal 2. So because this side of the statement is false, it makes the entire statement false because of the and here. And the and is represented by 2 ampersands. Okay, so both of these have to be true in order for the whole statement to be true. Okay, so let's see how that works. If 1 equals 1 and 2 equals 2, right? And then the statement would run if those two statements actually, run. Okay. If we did another if statement, if, 1 equals 2 and 2 equals 2, well, that would not run. Okay. So we need to make sure, because this essentially means true, and this essentially means true, which means this whole statement here is true. Oh, true. Now down here, this is a problem because this means false. This means true, which means the whole statement is false because you need both sides to be true in an and statement. Now, let's say we had an or, right? Or statements. Let's go down here. Or statements return true if either statement is true, right? So, for example, 1 equals 1 or 2 equals 1, that statement will return as true, right? Even though, right here, this is true, but this is not, it's still going to return true because both sides, or because one of these, only one, needs to be true in order for a true statement to be returned. Now this character right here, this is called a pipe. And the way you type a pipe is shift and then the key just above the enter key. So the backslash key. So shift and backslash. And it'll create a pipe. And so this is how we could use that statement. All right, now you might want to pay attention here because this might be pertinent to the assignment you're going to do this week. So if, user guess is, let's see, equals rock, and computer guess equals scissors, or user guess equals scissors and comp guess equals paper, or user guess equals paper, paper, and comp guess equals rock. Now, that looks crazy. I completely understand. That's a very long statement. But if you're paying attention, you might have figured out what I'm doing. So let's assume this user guess variable, which hasn't been created yet, let's assume that is where our user's going to type their guess, right? Either rock, paper, or scissors. We'll say if the user chooses rock and the computer chooses scissors, then who won? right? Well, rock beats scissors, so the user won. But let's go over here to or. Or let's say the user chooses scissors and the computer chooses paper. Well, who wins in that instance? Again, the user wins. Okay, perfect. Or let's say the user equals guess equals paper and the computer guess equals rock. Well, who wins there? Who wins there? Right? Paper. Paper wins because paper covers rock. So in all three of these statements here, this is trying to figure out whether or not the user won in a game of rock, paper, scissors against the computer. So if any of these statements returns as true, then we know that the user won that game, right? So it's pretty easy. I'm just saying, like, that's a lot of help that I'm giving you there. That's a very easy way to structure your rock, paper, scissors game later on. That's kind of cheating on my part, but you're welcome. Boolean logic is really, really helpful to understand. So if you go through this, if you actually understand this statement, then you're quite a bit of a long way toward understanding Boolean logic. All right, so or is pretty easy. If either of the statements in this sequence of statements, so if this statement is true, or that statement is true, or that statement is true, then the whole statement is true. Okay. Now let's get into not. Not is actually really easy. Not, or the exclamation point, returns true if the statement is false, returns false if the statement is true. Basically, this just reverses the logic of the Boolean, right? So if I say, let's do this. If, if 1 does not equal 1, then that's going to return, so 1, if 1 does not equal 1, well, 1 does equal 1, so that's false, which means this is going to return true if 1 does not equal 1. So that's going to be true. No, this is going to be false. Whew. Okay, so yeah, this is going to be false because 1 does not equal 1 does equal 1, so this is going to return as false. This is Boolean logic is complicated when you're dealing with nots. But the best way to deal with these is, let's say, remember this eligible variable we created up here for Boolean? This Boolean eligible? We could do something like this. If not eligible, eligible. If not eligible. Sorry, friend. We can write a statement to them saying, we're sorry. So if something is false, then this not statement will turn into true. If something is true, the not statement will turn into false. It's you're going to use it often to check to see if something is not something, right? So that's how you're going to use a not. All right. I think that's just about it. Now, just with conditionals, just all you're trying to do is determine if something is true or not. That's it. You're just trying to figure out if something is true. If this statement is true here, if this statement is true, and depending on whether or not this returns as true, will determine whether or not this code is actually run. So that's basically how conditionals and Boolean statements work. All right, that's it for me. I'm going to leave you to it and let you build your awesome, awesome, awesome rock, paper, scissors games. You're going to have a great time with it, I promise. And I'm going to leave you alone and let you get to it. And I will see you next week. Thanks.